So we already talked about the fact that we could find the greatest common factor by making a list. And we simply listed out the factors, found the one that was the biggest between the two, and that was the greatest common factor of those two numbers. Now the other way you can do it is by using prime factorization, like you were practicing yesterday. So if we went back to 32 and 40, and we did the prime factorization for each of them. So let's say for 32 we do 4 times 8. And what do we do to get 4 times 4? You're right, 2 times 2. And what about for 8? 2 times 4. And this 4 has to be 2 times 2. And there is our prime factorization for 32. So let's see. We have a whole lot of 2's here. 1, 2, 3, 4, 5. So 2, 3, 4, 5. There is the prime factorization for 32. So it's 2 times 1, 2, 3, 4, or 2 to the 4th. Now for 40, we can do 2 times 20. And 20 is 2 times what? 10. And 10 is 2 times 5. Alright, so we have 2 times 2 times 2 times 5. I know, I think the lists are easier too. But if you prefer the prime factorization, remember, I don't care which set of training wheels you use, they're all going to get us to the same answer. Now, how many 2's do we have under the 40? 1, 2, 3, okay? We can only use things that are the same on both sides. So for the 32, we can only use 3 of them. So that's 2 to the 3rd. What does 2 to the 3rd equal? 2 times 2 is 4, and 4 times 2 is 8. So we find the same answer as we did making a list, that the greatest common factor of these two numbers is 8. And that's how you would write your answer. Greatest common factor, GCF, and the number. The greatest common factor is 8. So if you prefer to do the prime factorization, you can, or you can do the list. Either way, you're going to get the same answer, and you'll know what your greatest common factor is. I hope it's helped. It's been awfully quiet here without you. Can't wait to have you back.